The next topic is submerged soils. We know the upland soil. Whatever the soil which is in the oxidized condition for the greater part of the growing season is known as the upland soils. Already we have studied the upland soils and wetland soils. Whatever the soils which are in oxidized state for a greater part of the growing season is known as the upland soils. And wetland soils, whatever the soils which are not in oxidized condition, these are in the submerged condition for the greater part of the greater growing season, then that soils are known as the wetland soils. Here, the upland soils are the oxidized condition soils for the greater part of the growing season. Submerged soils are the saturated with water for sufficiently long time annually to give the soil distinctive clay horizons resulting from the oxidation reduction process and having the high water table is known as the submerged soils. If we see the upland soil and submerged soils, here we can see the difference. Upland soils are always in oxidized condition for the greater part of the growing season, while submerged soils are the soils which are saturated with the water for greater part of the growing period, and it will give a distinctive clay horizon in the soil which is resulted from the oxidation reduction processes, as well as these soils are having the high water table. If we see the changes which occurs in the submerged soils, there is the depletion of the oxygen. As these submerged soils are filled with the water for a longer period, there is a depletion of the oxygen. There is removal of the oxygen takes place. Accumulation of the CO2. As we know, even though the soil is filled with the water, whatever the roots of the plants, these are always giving out the carbon dioxide, and that carbon dioxide gets accumulated within the soil horizon. Electrochemical changes, there may be the change in the pH, there may be the change in the redox potential, or there is change in the specific conductance. As and when the soil gets submerged, it will give the change in the pH of the soil, change in the redox potential of the soil, as well as the specific conductance or the electrical conductance of the soil. There is transformation of the nitrogen takes place as mineralization, accumulation of the ammonia. Then there may be the losses of the nitrogen by the denitrification. Whatever the nitrogen, it will react with the hydrogen and it will give the release of the nitrogen gas in the atmosphere. There may be the ammonia volatilization. There is the leaching losses of the nitrogen. There are also phosphorus transformations takes place due to the submergence of the soil. Iron, sulfur and manganese, these are reduced due to the formation of the submerged soils. This manganese oxide will be converted into manganese. Ferrous oxide will be converted into ferrite, as well as sulfate will be converted into sulfide, and thus it will reduces the iron, sulfur and manganese content of the soil. From the oxidation stage, it will be converted into the reduced stage, and reduced stage of this iron, sulfur and manganese will occurs due to the submergence of the soil. as well as the formation of the sulfide occurs in a strongly reduced environment. Thus, if we see the changes which occurs due to the formation of the submerged soils, first of all, there will be the depletion of the oxygen. There is accumulation of the carbon dioxide, which is given out by the roots of the plants. There are the electrochemical changes in the pH, redox potential, and specific conductance. There are transformation of the nitrogen as mineralization as well as the accumulation of the ammonia. There are losses of the nitrogen by denitrification, ammonia volatilization, and leaching losses. There are phosphorus transformation. Whatever the available form of the phosphorus will be converted into unavailable form of the phosphorus. There is a reduction in the iron, sulfur, and manganese. Formation of the sulfide will take place in the strongly reduced environment. If we see the management of the submerged soils, we should go for the leveling of the soil or the land. We have to adopt the mechanical drainage condition. We have to give the controlled irrigations, particularly in these soils. We have to adopt the flood control measures to avoid the submergence of the soil. Plantation of the trees having the high transpiration rate should be carried out in such a soils so that whatever the water content of that soil will be reduced. Check the seepage in the canals and irrigation channels. This will also help to minimize the saturation of the soil by the water. Selection of the crops and their proper varieties which can be grow even though under the submerged condition. We should go for sowing of the crops on the burns or on the ridges. As well as we have to follow the nutrient management practices, particularly for the nitrogen, phosphorus, iron, sulfur, and manganese. Leveling of the land should be carried out so that the soil will be leveled one and it will not give the accumulation of the water for a longer period. To remove the excess of the water, we should provide the drainage, mechanical drainage in that field or in that soil so that the excess amount of the water can be removed from the soil. We have to give the controlled irrigation as per the requirement of the crop. We should give the irrigation. We have to adopt the flood control measures, particularly near the river banks, so that whatever the river water, particularly during the floods, enters in the fields on the bank of the rivers and remains saturated for a longer period. For this, if possible, we should adopt the flood control measures. We have to go for the plantation of the trees which will have the high transpiration rate so that whatever the excess amount of the water that will be removed by these plants. As well as we have to check the seepage in the canals or the irrigation channels, which also gives the submergence of the soils nearby these canals or the channels. We should cultivate the crops or the varieties of the crops which can tolerate the submerged condition. We should carry out the sowing on the burns and ridges, as well as we have to adopt the proper nutrient management practices. Flooded soils, now known as the hydric soils, are the characteristics of the wetlands and irrigated field crop to the rice, or these are also said to be the paddy soils. If we see the definition of the flooded soils, water covers the soil or is present either at or near the surface of the soil all year or for varying period of the time during the year is known as the flooded soils. Whatever the soils on which water will give the covering or it is present either at the surface or near the surface of the soil all year or for varying periods of the time during the year, then these soils are said to be the flooded soils. Then we will see the impact of the flood on the soil. Flooded soils create the significant challenges for the agricultural lands. The floods have many direct impacts, in which the most prominent impact is the deposition of the sand and debris on the productive lands. Whatever the flooded soils, it will give the deposition of the sand particles or the debris on the productive lands. Secondly, it may cause the erosion of the agricultural soils, cultivated soils. Flooded soil syndrome, loss of the beneficial fungi which mobilize the soil-based plant nutrients. As and when the soils are flooded, there will be the loss of the beneficial fungi takes place, which fungi mobilizes the soil-based plant nutrients. As a result of this effect, after floods, farmers are challenged by the yield losses, devastation of the arable land. Subsequently, producers need to plan for the slow recovery of their arable soils. If we see the impact of the flood on the soils, these will give the deposition of the sand and debris on the productive lands. Erosion of the agricultural soils takes place. Loss of the beneficial fungi takes place. Farmers gets the less yield. The yield losses are there, as well as devastation of the arable land takes place. Hence, the farmers needs to plan for the slow recovery of their arable soils. Then we will see the impact of the flooding on the plant growth. Corn crop, which is grown on the flooded soil, showed the purple leaves that were disappeared in a week. You might have been observed these purple colors on the leaves due to the deficiency of the phosphorus. But this corn crop, which is grown in the flooded soils, showed the purple leaves, which will be disappeared after a week. Flooded fields with weeds or without tillage showed the less purpling than those tilled to the control weeds. Field with the high manure application history showed no adverse effect on the flooded soils on the crop. Whatever the fields in which the manure application is carried out for a longer period, then there will be no adverse effect on the crop or on the soil. Crop planted after the fallow or flood period will grow poorly. Phosphorus deficiency symptoms in the crops for corn, it is slow in the early growth and purple coloration. Flooded soils may have the normal P test level and low arbuscular mycorrhiza population. Whatever the flooded soils, these have the normal phosphorus test level and low in the arbuscular mycorrhiza population. To alleviate the phosphorus deficiency, high banded phosphorus rates needed twice or more than the normal recommended. If we see the impact of the flooding on the plant growth, we will observe the purple leaves formation, particularly in the corn, which will be disappeared in a week. Flooded fields with weed or without tillage showed the less purpling than the fields which are tilled to control weeds. Fields with high manure application showed no adverse effect for flooded soils on the crops. Crops which are planted after the fallow or flood period grows poorly. Phosphorus deficiency symptoms in the crops for corn, it is slow in the early growth and purple coloration will take place. Flooded soils may have the normal P test level but low in the arbuscular mycorrhiza population. To recover the phosphorus deficiency, to elevate the phosphorus deficiency, we need to apply the phosphorus or phosphatic fertilizers twice or more than the normal recommended dose of the phosphatic fertilizers. Post flooding soil management, we should go for the land leveling and sand cleaning. Sand cleaning depends on the depth of the accumulation. If there is less depth of the sand, then we can go for the cleaning of the sand from that soil. Few inches, that is 2 to 4 inches, can be incorporated in soil using the normal field operations. Otherwise, minimum soil disturbance is advisable to promote even weed growth till next spring. If sand is up to 6 inches deep, then moldboard plow to a depth twice the sand depth to incorporate in the field. If sand is 88 to 24 inches, it is advised to consider spreading to area with less sand and incorporate with special deep tillage equipment. However, it is advisable not to move the sand to fill lower or severely eroded areas in the field without proper topsoil to cover the sand. Sand about 24 inches deep, evaluate cost of removing sand, stockpile to decide whether to remove the sand from this field or not. And lastly, in case of the severe erosion and deep cuts, topsoil from the surrounding fields should be used to fill such areas. If we see the post-flooding soil management practices, we have to adopt the land leveling and sand cleaning. And this depends upon the depth of the accumulation of the sand. If sand is accumulated up to 2 to 4 inches, then it can be easily incorporated in the soil by using the normal field operations. If sand is up to 6 inches depth, then we can use the moldboard plow to depth twice sand depth to incorporate in the field. If sand is in between 8 to 24 inches, then we have to consider the spreading of the area with less sand and incorporate with special deep tillage. And if sand is about 24 inches depth, then we have to evaluate the cost of removing of the sand. And if it is feasible, then we can go for the removal of the sand particles. In case of the severe erosion and deep cuts, topsoil from the surrounding fields should be used to fill such areas. Soil testing should be conducted after any land leveling is done. As and when we are going for the land leveling, we should go for the soil testing. Soil sample should not be collected immediately after soils dry. May need to be collected in the spring or in the monsoon season. Need to allow time for phosphorus reactions after soil aeration. Potassium deficiency can occur due to the soil compaction. Soil test could increase from sediment depositions. Then cover crop. We can use the cover crop immediately after soil dries to promote the growth of the microorganisms which are essential for the nutrient cycling. Planting conditions should provide good soil seed contact to cover crop success. Whatever the cover crop which is cultivated, there should be the planting condition to provide the good soil seed contact to have a successful cover crop growth. Consider the wintering cover crop to provide the additional benefits of the continuous growth in the spring prior to the planting. When planting the soybean as a precaution seed, should be inoculated with the Bray Rhizobium japonicum to ensure the nodulation and nitrogen fixation. As and when we are going for the plantation of the soybean crop in such a fields, we have to give the seed treatment to the soybean crop with the Bray Rhizobium japonicum to ensure the have the nodulation as well as the nitrogen fixation in that soil. Arbuscular mycorrhiza fungi inoculation of the soil is not feasible. Once soil becomes aerobic, soil microflora will recover naturally. Questions which are asked on this topic: what is submerged soils? Give the changes occurs during the submerged soils. Define submerged soils and state the management of the submerged soils. What is flooded soils? Give the impact of the flooding on soil and plant growth. Explain in brief the post-flooding soil management practices which are adopted in the flooded soils. Likewise, these questions can be asked on this topic. This is all about regarding this topic.